problem where the degree of the word numerator is even 2 times higher than the degree of what the denominator. How do you solve a problem like this? Use the principle of what? Long division. Of course, we have solved a lot of problem. Of course, we're having this. We have x raised to the power 4 plus 2x cubed negative 2x squared plus 4x negative 1. Of course, the quotient is what? X squared plus 2x negative 3. A very simple concept. Use this to divide this. If s raised to the power 4 divided by x squared, this will be 2, so you have x squared. So you're having x squared here. That is the first thing. Use this x squared to multiply everything you have here. So you have x raised to the power 4. This will be what? Plus 2x cubed. This will be what? Negative 3x squared. Now, negative will open all the brackets. You're having negative here, and this will change to positive. Of course, you're going to work on this. This will cancel this. This will cancel this. So you're left with negative 2x squared plus 3x squared. You're going to be left with what? X squared plus what? 4x negative 1. Now you can see that the degree of this and this are equal. Of course, you're going to use this to divide this. So you're having a case where you're having x squared over what? X squared. This is going to be 1. So you're having plus 1. Of course, that 1 will open this. You're having x squared plus 2x negative 3. Of course, negative will work on this. This will be negative and this will turn to positive. This and this will cancel. Positive 4x negative 2x is going to be left with what? Positive 2x. Negative 1, positive 3 will be left with what? Plus 2. So therefore, you can see that if you work on this, you're having a case where you're having 2x over x squared. You're going to be left with 2 over x. This is not possible. We are avoiding fractions on quotients. Of course, everything here is called a quotient. We are avoiding what? Fractions on quotients. You cannot have a case where you have plus what? 2 over x. Please, it's not possible. So we normally stop here and say this is what? The remainder in this case. So please, you're going to get expression in terms of what? The remainder, quotient, and the dividend. So raised to the power 4 plus 2x cubed negative what? 2x squared plus 4x negative 1 over what? X squared plus 2x negative 3 is equal to what? X squared plus 1 plus what? The remainder 2x negative 2x plus 2 over what? The denominator, which is what we have here. So please, of course, the concept now we point arrows on what? This, because this can be resolved in what? Into what? Partial fraction. So you're going to bring that out. Okay, so we have something like this. The next step is what? To work on what? The denominator. The denominator here is what? A quadratic. Get it? We're going to open this. You're going to work on this. So you're going to work on this. We have x squared plus 2x negative 3. We're going to factorize this. Let's work on sum and product. The sum is what? 2x, and the product is what? Negative 3x squared. Which two numbers that when you add them you have 2x, and when you multiply them you have negative 3x squared. 3x negative x, this will result to 2x, and when you multiply this you have what? 3x into what? Negative x. You have this answer. So therefore we're going to put that values into here. So we have x squared plus 3x negative x negative 3. Want to factor out, so you're factoring x out. So we're going to have x plus 3. Factor out negative x, negative 1 out from these two. You have negative 1 into x plus 3. Of course, you can see in a case where the brackets are equal, which is pointing in one direction, that we are going in the right direction. It means we are going in the right direction. So we take one of those brackets that are equal, that are the same. Of course, we have x. Take this, negative 1. So these are what? The factors of that quadratic equation. So therefore, this becomes what? a linear factor in the denominator. So please, writing this, so we have 2x plus 2 over what? X plus 3 x negative. So please, we're not going to work on this. Very important, we're going to work on this. So of course, we're going to rewrite this from our general assumption. So we are assuming that what? All this is a over what? X plus 3 and plus b over what? X negative 1. Very easy. These concepts are becoming easy every time we work on them because they are the foundation. So please, if you don't understand some of these concepts, go down and watch the beginning of partial fractions so that you can get the knowledge of this stuff, because we have done a lot of sample problems. Of course, this problem should be is it the fifth or seventh problem, something like that. So please go back and watch those videos and understand that concept, then come back here and continue. I've brought down what we had here, the other part of the board, and which method are we going to use, because in our previous videos we have been solving problem on repeated linear factor, and we have been using equating the coefficients because that is the best method to use. But for today's class, we're having those linear factors, so the best method to use in linear factor is what? The cover up method. So using cover up method, the concept is still the same. If you're looking for A, cover up B, take these two. If you're looking for B, cover up A, take these two. So let's see for A now. So we're having for A, we're going to cover up B. We're going to have 2x plus 2 over what? X plus 3, x negative 1 equal to what? A over what? X negative 3. What do you notice here? This will cancel this, and you have that A is equal to what? 2x plus 2 over what? X negative 1. Now, the denominator of A, in this case, the factor under this is what? X negative 3. So you must say this assumption, let x negative 3 be equals to 0 and let x be equals to 3. We're going to substitute that value into here. We see that A is equals to what? 2 into 3 plus 2 over what? 3 negative 1. So we're having 6 plus 2 over 2. We're having 8 over 2. The answer is 4. So the value of A is 4. We're going to do the same thing for B. So we're having for B, we'll cover up A, take these 2. So we're having 2x plus 2 over what? X negative plus 3, x negative 1 is equals to what? B over what? X negative 1. This will cancel this, and you left it what? B is equals to what? 2x plus 2 over what? X plus 3. So the denominator under what? B is x negative 1. So you must say let x be equals to, let x negative 1 be equals to 0 and x equals to 1. So you put the assumption, substitute your value, you have that b is equals to what? 2 into 1 plus 2 over what? 1 plus 3. So you have 2 plus 2 and you have 1 plus 3, which is 4 over 4. B is equals to 1. So we have the value of B and we have the value of A. A is equals to 4 and B is equals to 1. Now substitute that value into this, of course, into this what we have here. So please, substituting the value, you can see that we have 4 over what? X negative 3 plus 1 over what? X negative 1. Oh, sorry, x plus 3. So we have 4 over what? X plus 3 plus 1 over what? X negative 1. Back to what we have here. Let's wipe this sum and product. We're done with it. Let's wipe this off so we can get our expression from what we are given to express into partial fraction. Given from the equation, x 4 plus 2x cubed negative 2x squared plus 4x negative 1 all over what? X squared plus what? 2x negative 3. Of course, we said that is equals to what? X squared plus 1, of course. Then we're going to we worked on this, right? This is what we worked on, and we have that what we have there on the board. So everything there is what? Plus 4 over what? X plus 3 plus 1 over what? X negative 1. So therefore, this is the final answer, resolving this into partial fractions. So the concept is very easy. Take your time to understand this concept because it's very important in partial fractions.